Oh, welcome and thank you for joining. Let's continue with another textbook question from page 111, number 15. We'll read the question first. Consider the function f of x equals 2x to the power 5 over 3 minus 5x to the power of 2 over 3. We have to determine the slope of the tangent at the point where the graph crosses the x-axis, and then find the value of a shown in the graph of f of x, which is given below. So first, let's write the information down. We have f of x equals 2 times x to the power 5 over 3 minus 5x to the power of 2 over 3. So when I write the information down, it also gives me time to think about the type of equation, so make some very quick observations. So as you can see in here, we have rational exponents. So it seems that both terms are cubic roots. So we are dealing with radicals here. And what we are trying to find is the slope of the tangent. So let's write that down here. So we're looking for the slope of the tangent. And again, I try to think, what does slope of the tangent mean in other words? So what are other interpretations of it? And that will help me actually make connections between what I'm trying to find and how I'm going to get it. So the slope of the tangent, or the derivative, we've said means the same thing. So we're going to say that we are trying to find slope of the tangent, or we're trying to find the derivative of a function, and we're finding the slope at a specific point, at a point where the graph crosses the x-axis. So the point where the graph crosses the x-axis is also called the x-intercept. And we know that at the x-intercept, the value of y equals 0. So again, always try to make these little connections in your head as you write the information down, because they will link your question with your information, which leads to solution. So, as we mentioned, to find the slope of the tangent, which is the main question asked in here, we need to find the derivative of the function. So we'll start off by finding the derivative f prime x, which will give us the slope of the tangent at any point or at any x value. So as you can see here, we have the power rule. Remember that the power rule states that if you are differentiating x to the power of n, then the derivative of it would be equal to nx to the power of n minus 1. So this is the formula we're using. So number 2 will stay the same. It's a constant. So the constant won't change how fast the term is changing as x is changing. So the only part of the term that is being differentiated is x to the power 5 over 3. So we have 5 over 3, which will become the coefficient. That's a power, right? That becomes the coefficient. And x will be to the power of 5 over 3, subtract 1. And then in a similar way, we differentiate the other terms. So we have 5, we have 2 over 3, and then we have x, power 2 over 3, subtract 1. And now let's clean up this expression. So we have f prime of x equal to, now 2 times 5 is 10, so 10 over 3. Now x will be to the power of, we have 5 over 3 minus 1 or minus 3 over 3. So that's x to the power of 2 over 3. And then minus, again, we have 5 times 2 here, so that will make a 10. Oopsie. Over 3. And then x will be to the power of 2 over 3 minus 1, or 2 over 3 minus 3 over 3. So that will make it negative 1 over 3, the power here. So we have found the derivative of the function, which represents the slope of the tangent at any x value. But what we are looking for is the slope of the tangent at exactly x-intercept. So we don't know exactly where the x-intercept is, but we know that the x-intercept would be at y equals 0. So we are going to work with the equation of the function f of x equals 2x to the power of 5 over 3 minus 5x to the power of 2 over 3, and try to find out where the x-intercept is located. So as we said, the x-intercept is at y equals 0, or in other words, when f of x equals 0. So therefore, we're going to say f of x is 0, and it is equal to 2x to the power of 5 over 3 minus 5x to the power of 2 over 3. So we have an interesting equation to solve in here, and we are trying to find the value of x that will make the entire expression equal to 0. So we're going to solve this by using factoring. So we'll try to factor the greatest common factor. You see that both terms have x, but different powers. So that means that we can factor out x, and the power we can take out is the smallest exponent. The smallest exponent is 2 to the power of 2 over 3. So power of 2 over 3. So here we go. We have 2, and then we have x. Now remember how we figure out what's left from this power. So again, I'm going to bring this classic example. So when we have, for example, x to the power of 3 minus x to the power of 5, and we're taking x power 3 out, it means that the power of 5 will be reduced by 3 because we've taken the power out. So what that means is that the power of 5 over 3 will be reduced by the power 2 over 3 that we took out. So what that means is that this will become 5 over 3 minus 2 over 3. And then we have minus. So the other term has a 5, and x to the power of 2 over 3 is already out. So it's just 5 on its own. So let's see what this looks like. Let's simplify it. So we have x to the power 2 over 3, nothing that we can do there. And then the other term will be 2 times x. 5 over 3 minus 2 over 3 will be 3 over 3, or 1. So that will make this 2x and then minus 5. So we're going to say that there will be 2 x-intercepts. One at x equals 0, and that's because x to the power of 2 over 3 is equal to 0 at x equals 0. So we have one x-intercept at 0. Or 2x minus 5 equals 0, which happens at x equals 5 over 2. So the next x-intercept will be at 5 over 2. So it seems that we have 2 x-intercepts, which means that we'll need to find the derivative of this function, or the slope of the tangent, at the x-intercept equals 0 and at the x-intercept of 5 over 2. So let's get to work. Now we are evaluating the derivative at 0, and we'll evaluate the derivative again at 5 over 2. So the derivative of this function is right here. And what we're gonna do is grab this entire equation actually and bring it on the next page because it's easier to see that way. And here we go. So this would be one of the derivatives, which will be measured at 0, and we're going to copy and paste it twice so that it's easier for us to organize the work. So keeping yourselves organized, or keeping ourselves organized, is so important. Alrighty then, when we write a solution, because then we can see the connections, right, between each and every step and whatsoever. So in order to find f prime of 0, it means that we will have to substitute x by 0. So we have 10 over 3. And here we'll have a 0 to the power of 2 over 3, and then minus 10 over 3, and here we'll have a 0 to the power negative 1 over 3. And the first term in here would be 10 times 0. And what I want you to do at this point is access a calculator and try to find out what the 0 to the power of negative 1 over 3 is. So we are so used to seeing 0 to any power equal to 0, but remember that 0 to the power of a negative number does not exist. And the reason why is because 0 to the power negative 1 over 3 is the same as 1 over 0 to the power 1 over 3. So we create a division by 0 in here, which is undefined, and therefore we're going to say that 0 minus 10 over 3 times an undefined number will be an undefined number. So therefore we're going to say that f prime at 0 does not exist. Or in other words, we're going to say at x-intercept equals 0, we can't draw a tangent. So either we can't draw a tangent because the function may be undefined, or chances are that we can draw a tangent that has an undefined slope, but the slope of it will be undefined. Now, we have talked about these different cases in class. So the cases when we cannot draw a tangent are the cases where the function is not continuous at 0. So let's take another look at our equation. So we have here, what we have here is f of x equals 2 to the power, 2 times x to the power of 5 over 3. I'm just going to copy it and bring it down here so we can discuss this more conveniently. So if x equals 0, let's check and see if this function is continuous or not. So in other words, if we're able to evaluate this function at 0, so we have 2 times 0 power 5 over 3, power is positive, so we're good, and then minus 5 times 0 to the power of 2 over 3. So you can see that we have 2 times 0 in here, power positive, minus 5 times 0, power positive, which means that the value of the function at x equals 0 exists. And actually, we're going to say that the way we found the x-intercept was by making the function, equal to 0. So we found this x-intercept at the y value of 0, which means the function is defined at that point, at x equals 0. So therefore, we're going to say that we are not dealing with a case where the function is discontinuous, but most likely we're dealing with a case where the function is continuous, but the slope of the tangent is undefined. So the function is continuous, we're able to draw the tangent, but the slope of the tangent is immeasurable or undefined. And we're going to say here, slope of the tangent at x equals 0 is undefined. Now let's take a look at our next x-intercept. There is 2 of them. So that means we're finding f prime at 5 over 2. So that means we are substituting x by 5 over 2. So 5 over 2 here and 5 over 2 in here. And we'll have 5 over 2 to the power of 2 over 3 minus 10 over 3 times 5 over 2 to the power negative 1 over 3. So what we have in this case is an expression that involves radicals. And we can very easily use a calculator to find the value of this term. And if you were to write this in radical form, that would look like 10 to the times the third root of 5 over 2 to the power of 2 minus 10 over 3 actually. 10 over 3, and then we're going to have 2 over 5 inside the third root and then squared it. No, power of 1, so we don't need the square here, sorry. Okay, here we go. So as you can see, this number exists, so we can find the third root of any number, not to mention that these are both positive. And if you use the calculator, then you'll find that this would be 10 over 3. We can factor out 10 over 3 to simplify the expression a little bit more. And then we'll have the third root of 5 over 2 squared minus the third root of 2 over 5 here. So this would be the exact value of the derivative at 5 over 2, but obviously we can determine the value of it by simply bringing the expression, the entire expression in the calculator. So that would be like 5 over 2 or 2.5 to the power of 2 over 3. Now, if you're using the calculator, remember to bring the power in brackets because it's in rational form. And then we have again 2 over 5 here to the power of 1 over 3. Let's see what we get. So what I got in here is 3.68. So f prime at 5 over 2 is 3.68. It seems that there is a positive slope at the tangent drawn at the other x-intercept. Okay, so if you were to draw the graph, then what you would see, and we can easily do this on Desmos, what we would see is exactly this graph in here. And this is what we're asked to find in here. Find the value of a shown on the graph of f of x. Now, the idea is that at x equals 0, this is where the slope of the tangent was undefined. As you can see, the function is defined because the function is continuous at that point. But if you were to draw the tangent line, you will see that the tangent line is vertical. And that's what made the derivative undefined at this point. So there is a cusp here. And at the other x-intercept, which was at 5 over 2, as you can see, the slope of the tangent was quite a big positive number, about 3.6. Now, in the next question, we're asked to find the value of a. So let's take a look at where this point is. It's a turning point on the graph. And we have to find the value of a shown on the graph, which means that, as you can see, we have a horizontal tangent, which means that the derivative here would be equal to 0. So what we did in here was find the derivative right here. So we found the derivative and we evaluated the derivative actually at the x-intercepts where y equals 0. But this time what we are trying to do is determine the derivative at the point where the derivative is 0. So we're going to bring down here the derivative. Sorry about that. So, okay, let me just grab this again. It's faster this way. So this would be question B. So in question B, we're asked to find, we had the graph of the function, which was something like this, right? So that was the graph of the function. And we need to find the point right here, a f of a, right here, which means where the tangent has a 0 slope. So when the tangent is horizontal, which means that the derivative must be equal to 0. So this time we are solving for f prime x equals 0. So that would be equal to 10 over 3, x to the power of 2 over 3 minus 10 over 3, x to the power of negative 1 over 3. So we are solving the equation for x. And what we have in here is a common factor of 10 over 3, which we can take out. And we also have x as a common factor. Now, x will have a power of 2 over 3 here and power of negative 1 over 3 here. So when we factor out x to a certain power, we take out the lowest power, negative 1 over 3 in our case. And then we have x to the power 2 over 3, subtract the power that we have factored. And then the other term is all out, which means that here we are left with minus 1. So that would be 10 over 3, x to the power of negative 1 over 3. And then in brackets, we'll have 2 over 3 minus negative 1 over 3 is 2 over 3 plus 1 over 3. So that will make the power 3 over 3 or simply 1. So we're going to say that the factors we obtain here are 10 over 3. That doesn't actually affect the 0, so only this part affects the 0. So we're going to write x to the power negative 1 over 3 is 0. Let's check and see if that can happen. So that means that 1 over x to the power 1 over 3 is 0. And that's another way actually to see how the negative powers we know will turn into null solutions. So if you make this into a fraction and you cross multiply, then we'll get 0 times x to the power of 1 over 3 equals 1 times 1. So 0 equals 1 is not possible, which means that the x value that guarantees that x to the power of negative 1 over 3 is 0 is non-existent. So the other factor here is x minus 1, so we'll make that equal to 0. So x equals 1. So we're going to say that the derivative of this function, f prime of x, will be equal to 0 at x equals 1. So the a value that we were talking about is equal to 1.